Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is our next problem. Problem having been chosen from the book Modern Physics by Paul A. Tipler. As usual, we first come to its statement. Okay. Suppose that an event occurs in inertial frame S with coordinates x equal to 75 meter, y equal to 18 meter, z equal to 4.0 meter at time t equal to 2.0 into 10 to power minus 5 second. The inertial frame S dash moves in the positive x direction with v equal to 0.85 c, where c is speed of light, that is 2.998 into 10 to power 8 meter per second. Okay, this is velocity is 85% of the speed of light. That is why we call this velocity as a relativistic velocity, and problem dealing with this velocity falls under relativity. Okay, because here velocity is approaching speed of light, it is comparable with speed of light c. Okay, the origins of S and S dash coincided at t equal to t dash equal to 0. Part A, what are the coordinates of the event in S dash? Part B, use the inverse transformation on the results of A, that is part A, to obtain the original coordinates. Okay. Two inertial frames are under consideration, S and S dash. Coordinates of S are given, while we have to determine the corresponding coordinates in S dash. Okay, we move to its solution, and in solution, first of all, we go through some snapshots which will provide us a guideline regarding the solution of this problem. Okay, so this is the first snapshot. This snapshot has been selected from the book University Physics. All these first two snapshots have been chosen from the book University Physics by Young Friedman. Okay, while third is selected from some other book. Okay, I am not sure about this third snapshot. Okay, so first we give an expression for Lorentz factor, okay, which we will find first of all in this problem. Okay, Lorentz factor denoted by gamma is equal to 1 over under root 1 minus u square over c square. Okay, where u is the speed of one frame of reference relative to another. Okay, u is the speed of one frame of reference relative to another, while c is the speed of light in vacuum. Okay, second snapshot, velocity of S dash relative to S in positive direction along x dash axis. Okay, Lorentz coordinate transformation, space time coordinates of an event are x, y, z, t in frame S, and x dash, y dash, z dash, t dash in frame S dash. Okay, so this transformation is that x coordinate in the S dash frame, x coordinate of uh, that point in the second frame, inertial frame, are defined as x dash equal to x minus ut over 1 minus under root 1 minus u square over c square, where u is the velocity of s dash relative to s in positive direction along x dash axis. Okay, this alternatively becomes equal to gamma x minus ut. Okay, where gamma is the Lorentz factor relating the two frames. Okay, x minus ut. Similarly, y dash is equal to y and z dash is equal to z. Okay, these two coordinates do not change because we are taking into consideration x dash axis. Okay, however, fourth coordinate, that is time, will be transformed. Okay, t dash becomes equal to t minus u x over c square divided by under root 1 minus u square over c square. This alternatively becomes equal to gamma, which we have already explained or defined in the previous snapshot. Okay, this alternatively becomes equal to gamma t minus ux over c square. Okay, third snapshot may be called an alternate approach. No, it is actually from x dash from s dash to s. In second snapshot, we have found x dash, y dash, z dash, t dash. Why in the next snapshot is about inverse transformation. Okay, that is x is equal to gamma x dash plus vt dash, while y and z do not change as in this second snapshot. Okay, while t is equal to gamma into t dash plus vx dash over c square. Okay, Lorentz transformation and inverse transformation. Okay, anyhow, these three snapshots provide us the guidelines regarding solution of this problem. Okay, we cannot go beyond the guidelines. Okay, now we come to solve part A. In part A, first of all, we find Lorentz factor gamma. Lorentz factor gamma is equal to 1 over under root 1 minus v square over c square. Here v is the relativistic velocity, which is 85% of speed of light, that is equal to 0.85 c square divided by c square. Here we have not disturbed c square. C square is as it is, while we have put the value of v in terms of c. That is, here velocity is relativistic velocity, and problem dealing with such velocity falls under relativity. Okay, in the next step, just simplification process. 1 over 1 minus 0.7225 c square over c square. Okay, what is this 0.7225? When actually we multiply 0.85 with 0.85, we get 0.7225. Okay, that is to say 0.7225 is equal to the square of 0.85. Okay, in the next step, c square will be cancelled with c square, and we will get 1 minus 0.7225, and in the next step we will get 1 over 0 under root 0.2775. Okay, when we will when we will subtract 0.7225 from 1, then it will result 0.2775. Okay, in the next step we have taken under root of this value, which is in the denominator. Okay, so it becomes equal to 1 over 0.52678. This alternatively becomes equal to 1.898. Okay, so first value, that is gamma, Lorentz factor, has been found, and it has become equal to 1.898. Now we move further in accordance with the three snapshots which are providing guidelines for our solution. Okay, now x dash is equal to gamma into x minus vt. Okay, in the next step we have just put relevant values in this expression. Okay, so in place of gamma we have used its value 1.898, while in place of x we have used 75 meter, which is given in the statement, and in the place of relativistic velocity we have put its value in terms of speed of light c, which is equal to 85% of speed of light. Okay, 0.85 c into t, where t is also given in the statement. Okay, so nothing else, just we have put the relevant values in this expression, and then it becomes equal to this into this into this minus this. Okay, moreover here we have used the value of c. Okay, in place of c we have used 2.998 into 10 raised to the power 8 meter per second. Remaining things are almost same. Next, just simplification. We do not need to explain these steps. Okay, it is quite clear from the screen. You can yourself reach the final value. Okay, final value of x dash becomes equal to minus 9.53 into 10 raised to the power 3 meter. Okay, we can also call it kilometer, but no need for kilometer. It is quite okay in this form. Okay, and we had shown in three snapshots that y and z coordinate do not change. Y coordinate does not change, z coordinate does not change. Okay, so y dash and y are equal. Similarly, in the next part, when we will come towards inverse transformation, then again this factor will be revised. Okay, y dash is equal to y equal to 18 meter, z dash equal to z equal to 4.0 meter. Okay, in the inverse transformation we will show that y equal to y dash equal to 18 meter. Similarly, z equal to z dash equal to 4.0 meter. Okay, now we come to next coordinate, that is time coordinate. T dash is equal to gamma into t minus vx over c square. Okay, next to this we will just put the relevant values in this expression. Okay, x is 75 meter, v is relativistic velocity, which is equal to 85% of speed of light. Time is given in the statement. C is a physical constant and its value is 2.998 into 10 to the power 8 meter per second. Okay, next simplification. We will not explain simplification steps. Okay, simplification steps will not be explained. Okay, quite easy. Everything is shown on the screen, and hence T dash becomes finally equal to 3.76 into 10 raised to the power minus 5 second. Okay, now we come towards part B, inverse transformation. X equal to gamma x dash plus vt dash. In the next step we have just put the relevant values. Okay, value of gamma we have found. First of all, value of x dash we have found in the previous step. V relativistic velocity is given as 85% of speed of light, and t dash we have found in the recent previous step. Okay, which is equal to 3.76 into 10 minus 5 second. Okay, next just simplification. Okay, simplification steps will not be explained. Okay, everything is clear on the screen. Okay, everything is clear on the screen. Simplification steps will not be explained to avoid wastage of time. Okay, and hence x finally becomes equal to 94.9 meter. Dear students, it is highly controversial. Actually, value of x is provided in the statement. Okay, it should be equal to that value which is given in the problem which is 75, okay, almost 75. We see, yes, x coordinate is 75 meter, okay. So answer is actually given in the problem statement, but we have just to counter check through inverse transformation, and unfortunately our result is varying to enough extent, okay. 75 and 94, there is enough difference, not negligible difference. If difference is minute, we can see that this is just a rounding error, etc, okay. But matter is quite concernable. I have tried enough to minimize this difference, okay. This is not equal to 75, this is becoming 94.9 meter, which is approximately equal to 95 meter. So dear students, you are requested to please check this step, only this part, okay, only this part, that it is not becoming accurate, okay. It should be nearly equal to 75 meter, but it is becoming 95, almost 95 meter, okay. So something questionable is involved here, which I have been failed in finding, okay. So I request you to give enough attention on this point, and if you find the reason of this difference, then please reply as a comment in our comment section of YouTube channel, okay. Now we move forward. In inverse transformation, y and z coordinate again remain the same, that is y equal to y dash equal to 18 meter, z equal to z dash equal to 4.0 meter, and now t is equal to gamma t dash plus vx dash over c square, okay. Next we will just put the values, okay. Gamma, first of all, we have found, okay. T dash we have found in previous part of this problem. V is relativistic velocity given in the problem, which is 85% of speed of light, and x dash we have determined in the previous step, which is minus 9.53, okay. C is constant 2.998 in 8 meter per second, okay. Next, just simplification steps. Simplification steps will not be explained because everything is clear from the screen, and hence value of t finally becomes equal to 2.0 into 10 raised to the power minus 5 second, which is exactly same which is provided in the statement, okay. Statement 2.50 into 10 raised to the power 5, okay. T and t dash are equal, t has become exactly same, okay. Only difference was in previous part, okay. Previous part x, okay, x coordinate has some difference, okay. 95 and 75, okay, about 20 meter difference. It is yet concernable, but in case of time there is no difference, it exactly becomes equal to time provided in the statement. T is equal to 2.0 into 10 raised to the power minus 5 second, which is provided in the statement. And this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.